Alright, we're going to drill a relief hole through here so that when we broach our straight 5/8 key in, that we will have a place for the tool bit to relieve and the chip to go. So we're going to put a 5/8 hole right here in this position right here. Okay, I'm going to pull out our chuck so we can run a 1/2 inch collet in here just to keep it nice and tight. And we'll come in here with a 1/2 inch, I think there's a 1/2 inch collet. And a 5/8 drill. And we're going to keep this a round hole, and then afterwards we're going to make a little 5/8 insert and put a grease zerk in it. We'll probably heliarc it into the OD here, just so it creates a seal and they can run a zerk here. Alright, we're going to want to slow this down because it was way too fast for the drill here. Alright. Alrighty. I'm just debating on whether I should go ahead and countersink that, and I think I probably should at least so you get some kind of a weld prep on there if I do, and if I don't, then at least I have a chamfer surface on it. So it's not so sharp. Alright, I like that. Alright, 5/8 dowel in here. I got some tension there. Let's see where we're at on squareness here. That's luck, okay? That's not skill because I just threw it up there. Alright, now we're going to go ahead and we want this to be down the bottom. We're going to cut the keyway across the bottom. We'll probably move these two pieces around here, so this is kind of like my drippers, and that hole's going to drip in here. Now I want this to go 180. Well, we can do that just by pulling our pin here, and somewhere in one of the blue marked pin holes that we have is going to be 180, and I don't know if it's the actual bottom pin or not. But we're going to go ahead and we're going to get this turned around here, and the closest pin is the bottom one. And understands the reason that we were doing exactly 14, and exactly 14. I don't know. We're gonna pull this out of here, and I might get a short stub there because there or there. It's hard to say. I'd almost have to say it has to be the one straight across because it's going to be exactly the right amount of turns and lines, and that would be it there. But we're going to go ahead and I got to find a shorter 5/8 to eyeball and stick it in there and give it a quick eyeball anyway. This 5/8 pin here and small square, we put it underneath there and we're square. Alright, so it was the bottom pin, and we're locked down, and we're 0 on our travel here with our indicator and everything else still on this diameter, and everything is set up with this diameter here. Now we're going to go ahead and we're going to take our other tool bit, and we're going to go ahead and we're going to silver solder another insert or another tool bit into it. And that really looks good. Minimum wear on it. Alright. So we're going to go ahead and we're going to take another piece of that 1/4 inch and we're going to grind it so it'll be just a straight pusher. Alright, I have one right here, but the depth that we're going to make that is going to be 5/16 on the outside edge on the depth there. The 5/16 by 5/8 key is what's being used, and this is a little bit under 1/4 inch, so this wouldn't make it at all. So it's going to be an identical tool to this, except for the tool bit is going to be sticking out a little bit farther so that we can create a deeper keyway. And then we're going to come in and we'll broach into that opening hole there so that the chip has a place to relieve itself. And we'll go ahead and we'll create a 5/16 deep by 5/8 wide keyway in this side here, and then the job is done. I've already got this mounted in, so I'm not going to pull it out and actually show you, but this is the new straight cutter for the keyway that we're going to be putting in this piece here. And it's 1/4 inch right here at the edge, and then it's relieved inward and backwards behind. Also, I put a slight little bit of a curve or a V in the bottom with real shallow. So I'm going to be coming in and I'm going to be feeding this thing side to side a little bit at a time, and we're going to work 5/8 wide, 5/16 deep, and we're set up on 0, just the same as we were with the other spline. Now I wanted to show you, this is the bit here, and you can see hardly anywhere. In fact, actually that surface right there is kind of where I had stoned it, but the edge still very good. And you can see the rub on the face is about, the chip was curling, you know, when I was cutting the depth. You got the one on the bottom, and then each one of these on the sides here is when I went side to side to get that spline. Alright, now this would be a tool that I'll just keep in a rack, and if I need to reshape it or I need to do something else, or this job comes up again, I've got the tool here to go ahead and help make another coupling. Alright, now I'm going to go ahead and get this in position, and we're going to go ahead and get this keyway in here this morning. Then this part is done and we can move on to our next job. Alright, let's see, we're going to spray some dye in here. Actually, let's move this back a little bit. little bit of oil right there. Okay, we're going to let that dry and then we'll bring it back in and we'll set it back up to our 0 mark again. Before I get the machine running and we have that noise coming on, what I'm going to do is, I've already got the spray blue here. This is 1/4 inch wide. The groove is going to be 5/8 wide. So we're going to be traveling 3/16 each way. Because the 1/4 from the 5/8 is 3/8 and that's split in half. So what I'm going to do is I'm going to come over to each of the 2 sides 3/16 of an inch, and I'm going to go down and I should be putting 2 lines. That will be our width of the keyway, and also that will be our 0 mark for our depth. And then from there you'll see me just continue down and going from side to side. And I'll leave it a little shy on a total width because I can make those in straight down cuts because of the way I've cut and designed my bit here to be pointed and relieved on both sides, both corners and the bottom. Alright, here we go. Okay, I'm just putting it in here so I can get a quick eyeball first. Now we're going to go 187. Actually, we're going to go just a little bit shy of that. We're just going to go 180. About 7,000 shy on both sides. Alright, now I'm bringing it down to where I can eyeball, where I'm semi-close. And I'm going to go ahead and take and loosen my dial. I'm just explaining what I'm doing out here. Alright, now we're going to go ahead and start the stroke. Now I'm just going to come down until I just make a line there. Just take the die off. Okay, there I go. Just created a scribe line. Okay, I'm going to set my dial 0 right there for my depth. That's 0 on the knee of the mill. Alright, now I'm going to go ahead and crank it, and I've got my dial set up here where just like you saw on shifting it side to side for the spline cut, I'm doing the same thing on the key. So now I'm going to come over, as this is running, I'm going to come over the 3/16, the other side of 0, and we should be touching over there if the bottom of my tool bit is square or really close to it. Okay, there's 0. There's 100. There's 150. 160. 170. 178. 180. Right there, I should be touching. Okay, now I'm going to crank the table up until I touch, just so I know how far off I am from one side to the other side. Alright, I got about 8 thousandths on my dial. So one tip of my cutter is about 8 thousandths different than the other side. I'm going to let it fly like that. That's not drastic. But there's our mean width right there of our keyway. Now I'm going to go ahead and I'm going to reset my 0 at that point right there, because I want to make sure that I have every bit of my depth accounted for, and I don't want it to be shy on that side and heavy on this side. So I would rather have a little extra on this side and have it just where I tend to have it there. Alright. Now we're going to come back to 0 in our center. Okay, now we're going to start with the first cut of the depth there, and we're just going to add a little bit of oil here. Okay, I just got the touch on that side there. There we go. Now you can see that the hollow area in the middle is the hollow of my cutter. Alright, that was 35 thousandths from out the edge to where it's touching in the middle. So that's the slope or the curve of the bore. Okay, I'm going to go ahead and feed it down. That's getting rid of that center hollow area, and I'm at 55 thousandths here. Now I'm going to go ahead, I'm going to feed it side to side at that point right there. This first cut is really going to judge if I'm ending up with my cut at center of the relief hole in the inside there. And this is just like coming across with it if you were a shaper. That's 160 right there. 170. 175. Alright, there's our 180. Alright, now we're going to come back the other direction. Starting on the other side now. I'm taking about 10 thousandths at a time, and I crank that in as soon as I'm out of the cut. So between when it comes out of the bore and goes into the bore is where I make my maneuver for my next amount of material taken, advancement of cut. There's 60, 65, 70, 75, 80. Okay, now we're going to come back to 0 again. And there's our first pass. Down, we're going to go another 50,000 straight down. couple times there. Alright, now we can go ahead and start our side to side again. And about 5 thousandths each time it comes out of there. There's 150, 160, 65, 170, 175, and we're sneaking up on the 180 here. Okay, there's 180 right there. Okay, now we're going to go to the other side. And we're at 0, 5. There's 150, 160, 170, 75, okay, and 180 again. Okay, back to 0. Alright, we just finished our last cut of 50, so that puts us about 300 deep, and by using our dial calipers here, we're about 6.5 or so, but I want to know a little bit better than just using my calipers in there on what that width is. So I'm going to drop in an adjustable parallel, and of course I can put the butt end against it here and I can draw it towards me, and that feels a little bit more maybe. There we go. Alright, I can push on one side. There we go, we got it spread in there now. Okay, alright, and of course I'm just reaching in here with the dials, reading in this dimension here, and we're right at 600, and we want to just make sure that we are, well, there we go. Yeah, we're snug in there now. Okay, I'm getting about 600. So we've got about 10 thousandths to go on the width. And remember, we went 180 on our width, and we can go 1.875 was our dimensions in there, and there's a little bit of spring pressure and stuff like that. What we're going to do here now is we're going to come over and we're going to feed down on this side here, and then we're going to come over there and we're going to feed down on that side there using our whole 187.5 thousandths shift side to side. And then we're going to go down and we're going to touch that bottom. We're going to take the last 10 thousandths and come across, and then we're going to come back to this and then check it again. And if it checks out, then we're going to take a piece of 5/8 key stock and we're going to drop it in there and see what we got. We'll move it back away from our tool bit for that check. But for right now, I'm happy where it's at right now. All right, we're going to go ahead and set up and start over here on the top and then feed on down. Okay, we're in position. Up. Alright, we're just feeding it about 5 as we go each stroke. Another 30 thousandths. Okay, we're down at the bottom. Okay, we're going to crank it back up. I'm just holding it to the side there so I can see where I'm going to be at for 0. That's pretty close to it. Okay, now we're going to be cranking in the other side here. Okay, there's the 187 right there. Give it a dab of oil here. Another 30. Now we're going to come across the bottom at 10. Okay, there's the extra 10 there. We're going all the way from that side all the way across to the other side. Okay, now we're coming up to the corner, and right there's the corner. Okay, we're going to blow it off and move it out, and we'll bring it back. We pull this back out of the way here, and we pushed our parallels in here. And I'm getting about 2 thousandths over. This is a piece of 5/8 key stock, or not key stock, but tool bit. Right on the money here. It fits good. This thing has got to go between two parts that have got to be slid together, and we might still be a little bit tight on the bore, but I wanted it a little bit snugger because the shaft that this is going on is worn. And so anyway, we're going to deburr all of this right in here. I'm satisfied with the keyway as far as the depth and the width and the finish on the keyway. I got nice smooth sides. Okay, there's no steps, no ridges, there's no false width to it. It is 100% true. 2 thousandths wider than the nominal 5/8 key stock, and I'm good with that. Now I'm going to take this rotary burr, and basically what I'm doing is I'm going to go in there and right around the inside rough area where that hole come through and where the relief is in there. I'm going to massage that so it's all like rounded and smooth. Okay, I like that. We'll give you a picture of what it looks like inside. Alright, the last thing I think I'm going to put on there is a pair of holes, tapped holes, 1/2 inch 13, for 2 square head sets to come in at 1/3 radius around from the key here to help support the solid end. The spline is going to be in and out sliding, and that opening we're going to go ahead and turn a little slug with an 1/8 inch pipe thread on it, and we're going to put a zerk in there so that they can always pump grease in. It'll go into that circular relief in here and feed the splines because their alignment is not 100% on their bracket, and I think a little bit of lubrication is going to help create a comfort zone there for the splines to run. Alright, so what I'm going to do right here is jack up my speed and get a hole in here and tap it. Alright, now we'll go ahead and we'll get the back and clean this up, and we're going to rotate it and we'll do the next one. Well, I'm all wrapped up on this job here. I went and did a few final touches on this, and that was putting a plug with a tapped zerk in it, welded it into the bore there that we use for the relief for the stroking of the keyway. We are happy with all of our dimensions that we come out. Now this goes between this motor and a winch, and the winch is already all fabbed. The shaft sticks through into this area that joins the flange that this mounts to, and it's all a weldment all around where that shaft comes. And so this will be slipped into place, and I added two locking holes for like giant square head set screws, and I oppose the keyway because that way it pulls against the shaft in that direction there and gives you a firmer support around here, just like you do in marine shafting on the solid bore couplings. And this, you've seen from the beginning of the video to the end, this thing got a little shorter each time, and that's because all of the factors came in on the dimensions that this component is going. Now the difference between the splines here and being a little bit smaller than the 2 7/16 shaft and the 2 7/16 diameter interfering going the other way, this coupling really will fit in between the two of them without moving. It has no place to go. One of the split lines will interfere with the other from traveling. So my only concern was just to give it a little bit more secure lock on the straight shaft, and the little bit of misalignment that they have on the flange where they're going to be mounting this motor. The little bit of play that I gave in on the splines and the grease fitting will let that area work. Now this shaft is hardened. The shaft that the winch has in it is not hardened. And this is a piece of 8620 with chromoly, and it's a annealed state. It's pretty stout stuff. And I chose to leave it untreated so that we had differences of materials and allow for wear and not create brittle against brittle on a spline A lot of, I mean, there's a lot of stress areas right in here, stress rising areas if you consider them as far as torque. So I didn't want to have any pounding or any chance that this thing would be breaking up. That's my best shot at giving them what they want, so they can put this hydraulic motor on direct drive with the shaft instead of running a sprocket chain and the other assembly that they had on there. This will be a much better performance, more control, and also hold up to the elements. This thing's going to be out on a barge, and there's a lot of salt air and a lot of corrosion happens over the years, and of course they do maintain their equipment really well, and you know, I'm not saying that there's abuse in that area. It's just the elements are pretty harsh to start with. Alright, I'm happy with this, and we're going to move on to the next one. Get her done.